Hey students, this is lesson 7-1. We're going to start by kind of reviewing some equation solving and trying to figure out what is the most appropriate way to solve equations. Let's start by reviewing backtracking here. So I'll just show you an example and then I'll let you try a couple here. But basically when you're backtracking, so we're trying to figure out what x is in this equation right there, x. And we know that in the equation, x is multiplied by 2, then 6 is subtracted from, and in that order. Then it's multiplied by 2 again, then divided by 4, then multiplied by 6, and when all that happens, it equals 12. Well, if you can identify the things that are going on with the missing number, x, then if you reverse that process and use the inverse operations, you can find the answer. So, and we can use a diagram here to help us. Notice that I have these little arrows in here that are showing we're going two different ways here. So let's start with our x here. So we're talking about this x right here in the equation. So here's the x right there. First thing is happening is it's multiplied by 2. So to get to the next value, we need to multiply that by 2. Then after we multiply by 2, we're inside the parentheses yet. Then 6 is subtracted from it. Now we're right here. Next thing is multiplied by 2 again. Then we go down here, we're dividing it by 4. Then out here is next, multiplying by 6. And after we're all done with that, we end up with 12 for an answer. And I get that from right there. Now, if I can identify the inverse operations of all those and work backwards, I can get back to the answer. So I'm just going to write down what the inverse operations here are. The inverse of multiplying by 6 is dividing by 6. The inverse operation of dividing by 4 is multiplying by 4. And so on. The inverse of multiplying by 2 is dividing by 2. The inverse of subtracting 6 is adding 6. And the inverse of multiplying by 2 is dividing by 2. Now that I know all those, I can just work backwards. So I'm just going to take my 12 divided by 6, and that's going to give me 2. Then I'm going to multiply that by 4, and that's going to give me 8. Then I'm going to divide that by 2, and that's going to equal 4. Then I'm going to add 6 to that, and that's 10. And then the last step, divide by 2, is 5. So if I start with 5, multiply by 2, I get 10. Subtract 6, I get 4. Multiply by 2, I get 8. Divide by 4, I get 2 times 6 is 12. And then you just want to check your answer. You want to do 2 times 5, which is 10. Minus 6 is 4. Times 2 is 8. Divided by 4 is 2. Times 6 is 12. So my answer for x is 5, and I do that by backtracking. I'm going to do a couple more with you. I'll do one completely and then just help you set up a couple. So we want to know in this case what n is. And we notice that n is divided by 2 first. Then 1 is subtracted from it. Then it's multiplied by 3. And after that happens, I get 15. So I really don't even need those 2. All right, now working backwards, we're going to need to divide by 3, add 1, and multiply by 2 to get n. So 15 divided by 3 is 5, plus 1 is 6, times 2 is 12, so n is 12. And then you just want to check that, make sure that's true. 12 divided by 2 is 6, minus 1 is 5, times 3 is 15, that works. All right, this next one, I'm going to just help you set it up. We're looking for n. First thing that's happening is 1 is added to n. Then it's multiplied by 2. Then 3 is subtracted. After all that happens, it's divided by 4. And after I do that, I get 5. Working backwards, we're going to have to multiply by 4, add 3 there, divide by 2 there, and subtract 1 there. So 5 times 4 is 20, plus 3 is 23, divided by 2 is 11.5, minus 1 is 10.5. So 10.5 plus 1 is 11.5 times 2 is 23, minus 3 is 20, divided by 4 is 5. That works. All right, I'm going to just let you do this one. I'll just get you started on it. So we're looking for n. First thing that happens is dividing by 4, then subtracting 3, then times 2, then add 1, and it equals 5. So the inverse operations of all of these, I'm going to write them down. And I'll go back to 5 and do the inverse. Subtract 1, divide by 2, and so on. See if you can get the right answer. All right? So that's backtracking. Now, sometimes once you get good at backtracking, you want to just do it mentally as much as you can. Like in this, to find m here, I know that 3 is multiplied by m, and then 4 is subtracted from that, and the last thing that happens is it's multiplied by 6. So working backwards, I would start with 12, and then just mentally, instead of multiplying by 6, I would divide by 6, and that gives me 2. And then the next thing in order was subtracting 4, so I would add 4 to 2, and that would give me 6. And then the last thing is multiplied by 3, so I would do the inverse of that, which is divide by 3, and that would give me 2. And so 3 times 2 is 6, minus 4 is 2, times 2 is 12. So you can do a lot of this work mentally, and I wrote it down, but if I was actually doing it, I probably wouldn't write it down. So go ahead and try number 5, see if you can get the answer just by thinking what the inverse operations are working backwards. So, and think about what order they have to go. So, and just a reminder, this first thing that's happening to m here is multiplied by 3, then divided by 4, then added 4, and that equals 12. So when you're going backward, you have to do it inverse and in the opposite order. All right, some things we can't use backtracking for solving. Alfonso tried to solve this equation, 3a plus 4 is equal to 2a plus 7 by backtracking. Why do you think he had trouble? If you want to pause here and think about that. The reason is because you can only backtrack if you have your variable in one spot, and in this case we have the variable in 2 places. So in order to get to the point where you can backtrack, you have to somehow create an equation that only has one variable. And the best way to do that here would be doing the same thing to both sides. And if you think about that, let's say I subtracted 2a from both sides. Then on this side I would have a plus 4, and on the other side I would have 0 plus 7, which is just 7. And now I have a in one place, I can just backtrack, and I would just do 7 minus 4, which is 3. You can also do the same thing both sides, finishing that process, and get the result that way also, a equals 3. So you're trying to find operations you can do to both sides to simplify the equation to the point where you can backtrack. So on these, we're going to practice doing the same thing to both sides. I'm just going to do one with you, and then we'll save the other ones for in class. So we'll do number 9. It says 7 minus 5x equals 12 minus 3x. So we have x's on both sides, and what I'd like to do is have x's on just one side. Now I could do this 2 ways. If I added 3x to both sides, I would eliminate the 3x here. If I add 5x to both sides, I would eliminate 5x here. And that's the one I'm going to choose to do because adding 5x to negative 3x gives me a positive number to work with, which I prefer. So I'm going to add 5x to both sides. Now 7 minus 5x plus 5x is just 7. And 12 minus 3x plus 5x is 2x. Now, if I continue this process, and I could have, once I have x in just one place, I can backtrack if I want. I could just do 7 minus 12 divided by 2. Or I can just continue this process, eliminate the 12 there, and that gives me negative 5 over here. 12 minus 12 is 0, so I just have 2x. Now all I have to do is divide by 2. And I get negative 2.5 is equal to x. All right? And In this equation, Casey thought that the equation might be easier to solve if she simplified it, so x appeared only once, simplifying. And so here, again, we can't use backtracking because x is in more than one place. But notice that the x's are both on the same side of the equal sign, which means we can't do something to both sides to get rid of an x. But you should always think, is there a simpler way to write this? And there is. 3x minus 2x is just 1x, and 2 plus 2 is 4. So a much simpler way to write this is 4 times quantity x plus 4 equals 20. Now I can work backwards if I want. And so, and if you can do it mentally, go ahead and do that. X, the first thing that is, you could set up a flow chart also. I don't know how many circles I'll need here, but maybe 4 of them. All right, so to get x, the first thing that's happening is added 4. And then it's multiplied by 4. And then that equals 20. And so working backwards, we're going to have to divide by 4 and subtract 4. So 20 divided by 4 is 5. And 5 minus 4 is 1. So x is 1. And we'll just check that in the original equation, make sure that works. 3 times 1 is 3, plus 2. 2 times 1 is 2. And hopefully that will equal 20. 3 plus 2 is 5, minus 2 is 3, plus 2 is 5, times 4 is 20, so that works. All right. So in each of these, simplify them first, and then solve using any method you choose. If you like doing the same thing to both sides, that's cool. If you like the backtracking, then go ahead and do that. I'll do this middle one with you. So we can see there's n's in 2 places here, so we need to somehow simplify that. First thing I'm going to use is the distributive property, I think, here. So I'm going to make this negative 48. And then we have a negative times a negative, which is a positive 18n plus 2n equals negative 8. And I can combine the 18n and the 2n and just make that 20n. And so I get that. And I think that I'm going to just continue doing the same thing to both sides. I'd like to get rid of this 48 here. I'm going to add 48 to both sides. That makes that 0 plus 20n is 20n. And negative 8 plus 48 is 40. Now I can just divide both sides by 20 to get n equals 2. All right, and then you'd certainly want to check that to make sure that's good. All right, we'll do the rest of those in class. And I'm going to end this lesson here. We're going to call this lesson 711A. And then for part B, 711B will be another lesson.